the final public oral for Ian Manley, who will give a 45 to 50 minute.
More or less.
More or less. More likely more than less based on the practice. Talk on his thesis. He will then take questions from the audience. After that, we'll dismiss the audience so that the committee can spend time going into some of the details of the thesis. So his thesis is Data Mining and Intervention in Calculus 1. Take it away, Ian.
All right, well, thank you all for coming, especially for my committee, of course. that's pretty important. But I'd also like to thank some of the people who've traveled thousands of miles to come see me do this and support me. I really appreciate that. Okay, so what I'm going to be talking about today is my thesis, which is Data Mining and Intervention in Calculus 1. So I spent the past several years looking at the calculus course and another course called Bailout Pre-Calculus, which I'll get into a little bit, and studying the students in those courses. Okay, so why would I spend so much time studying Calculus 1? Well, if you're a new freshman coming in about 4 weeks, class of 2022, which makes me feel really old, if you're some sort of STEM major, you're more likely than not going to have to enroll in Calculus 1, assuming you don't have AP credit for it or something like that. And so consequently, since it's a prerequisite for many courses in STEM majors, it's very important that you do well in Calculus 1 when you're enrolled in it. So the pressure's on for students enrolling in it. But Calculus 1, at least offered at K-State, is a bit different from high school courses. It's going to be a large lecture course, which can be intimidating and difficult for many students who are used to, especially at K-State, coming from high school classes where you have maybe like 10 people in a class. You're going from 10 to 250 to 300. So it can be a bit intimidating and difficult. People could be unprepared, have poor backgrounds. So what I investigated is what happens when students do poorly and how they can be helped. So most people here go to K-State, but just let me go over what Calculus 1 is like at Kansas State, because it's different elsewhere. It meets 4 times a week, so it's a 4 credit hour course. There are 2 large lectures given a week, which are 50 minutes each by one of the faculty members. You go over the material, present, give the idea, proofs, etc. But then there are 2 recitations per week, which are smaller, tend to have 30 to 40 students in each one, and this is more for going over problems and practicing the material, more so than introducing it. And students are placed into Calculus 1 at K-State based on some combination of how well they did in high school, how they did on standardized exams, and we have our own in-house math placement exam here. So if they do well enough on the algebra and trig sections of that, then they're advised that they can take Calculus 1. Okay, but as I mentioned earlier, and as many of you know or at least heard of, not everyone ends up doing well in Calculus 1. Not everyone is prepared to face that challenge. So what is to be done to help out students who need it? I've chosen to investigate this problem in 2 different ways. I chose to use data mining techniques to investigate Calculus 1. Now, data mining has been a tool used in business and industry for the past about 50 years or so, but more recently it's been used to analyze educational research, because for a class like Calculus 1, where sometimes there are upwards of 800 students enrolled in it in its entirety, it's difficult, like those are large numbers. So you want to use data mining to understand what's happening in that course. And the hope for doing something like that is that you could differentiate instruction in a large course. Even the most dedicated instructor can't get to know their students personally when there's 800 of them. So with data mining, what you want to do is you want to break students up into clusters based on their scores, and hopefully students who perform in the same ways maybe think in the same way, and then you could develop teaching techniques to cater to each of those students. So that's kind of the aim for that. Now, what if you find out that a student is really struggling and it's unlikely that they're going to be able to make it through Calculus 1 without some help? Well, I also investigated what are known as intervention courses, or sometimes they're kind of run as concurrent programs with Calculus 1, where students who are struggling get some help. They can review older material, and oftentimes there's a psychological boost to these intervention courses. And in particular, for Calculus 1 at K-State, there is an intervention course called Bailout Pre-Calculus. If a student does poorly on their first midterm, they're offered the chance to have all of their records of Calculus 1 erased, including their scores. And for the remaining 10 weeks-ish of the semester, they enroll in a newly created pre-calc class where they can not only shore up their algebra and trig weaknesses, but go over the same calculus material that they did poorly on in the first few weeks, thus giving them a morale boost if they choose to take the class again. Okay, so to guide my investigation, I had 3 main research questions. So the first one has to do with the data mining. Is it possible to break Calculus 1 into different groups where hopefully the students in each groups are somewhat similar to each other and teach to each of those different types of groups? And if there are sensible groups, what kind of groups are they? My second question is it possible to quickly identify students in need of assistance? Yeah, sure, you can look and see if they do poorly on the first midterm, but that may be a little later in the semester than you would like. And also there are some students who happen to do well in the first midterm but may perform poorly later. So can we detect students who are at risk? And if those students are at risk, is this bailout pre-calculus thing that I mentioned, is that any good? Does that help them in any way? And finally, if it is helpful at changing their trajectory of their college career, why? Why is it so good? So those are my research questions, and I had 3 hypotheses to go with them. I predicted that yes, indeed, students in Calculus 1 can be clustered sensibly based on data mining and interviews. And as for the second question, I was like, yes, it is likely that we can identify students who are struggling in the beginning. And I predicted that bailout pre-calculus is in fact a good way of strengthening these students' careers. And I predicted the why. Why is it going to be good? It's not only a review of the material that they may be weak on, because for anyone who's taught calculus, a lot of the issue is their algebra and trig skills more so than the new calculus skills. So it not only acts as a review from that, but by going over the calculus that they previously failed, and by having a smaller, more intimate environment where they can feel less intimidated, they gain confidence as not only mathematics students, but just students in general. Okay, so with these questions in mind, I did a literature review. My study is very similar to one done by Rachel Manspeaker, who was Dr. Bennett's previous student. And she did this data mining stuff with college algebra, particularly studio college algebra here at K-State. And she found out that there were 5 different clusters that studio algebra usually broke into. And she did this across multiple semesters because maybe the clusters change depending on what semester you're in, but she found out that they were actually relatively stable. They had the same 5 clusters every semester that this was done. Sizes changed a little bit, but mostly the same. And then